Hey everyone, this is the first video of a trilogy on what is known as scientific consensus. Likely the best starting point for getting to the bottom of any scientific claim or subject is to review what the scientific consensus is on it. Very simply, it is the collective position of scientists within a particular field implying general agreement, not necessarily unanimous agreement. It's something that emerges once enough data and evidence are compiled that point towards a particular model or conclusion, weighed against any contrary data. Consensus is typically established through scientists convening at conferences, through the publication process, through peer review, or sometimes through surveys. Oftentimes, position papers will be issued to communicate what the scientific consensus is to outsiders of the field, or to the general public. Sometimes, scientific consensus positions will be formalized to the extent that major academic bodies will issue official statements declaring consensus on particular issues. Such has been the case for anthropogenic or man-made climate change, the health and environmental safety of genetically modified organisms, and the theory of evolution. Other times, such consensus is not transparently or accessibly communicated to the public, and it may be difficult for the non-scientist to figure out what the consensus is or how strong it is. So why should we care about scientific consensus? Isn't this just an argument from authority? Well, yes and no. It's not an argument from authority fallacy, in the sense that one is claiming that something is true simply because most scientists believe it. But it is an argument from authority in the sense that the overwhelming evidence that has forced the consensus is the authority. A basic component of science literacy is the concept known as consilience, which is the indication of large bodies of evidence from independent sources that have converged to a particular conclusion or explanatory model. Finding such a convergence of evidence is integral to the process of science and is itself evidence for the reliability of the methods themselves. This doesn't mean there won't be deviations in findings, since scientific experiments and studies are never perfect. However, if the convergence of evidence and thus consensus is robust enough, then the evidence inconsistent with the consensus is not enough to overturn it. Misunderstanding of this concept often leads to science denialism, which is a topic I'll cover in future videos. We must give scientific consensus due respect because scientific consensus represents the collective position of the world's foremost trained experts in a given field. What better alternative do we have for a reliable, consistent metric for evaluating claims? As untrained non-experts, you and I must at least use the consensus position as a jumping-off point in figuring out the best answers to scientific questions. If we discard it as a metric, what alternative do we have available to us? Do we just appeal to whatever makes sense to each of us individually as non-experts in a sort of arbitrary manner? That simply isn't reliable if our goal is to arrive at the most reasonable explanation or answer for a given scientific issue. Of course, it is true that in practice, the scientific process cannot exactly be separated from the individuals who carry it out. But this is even more reason why consilience or consensus is needed to move it forward. Let's also be careful not to equate the scientific consensus with the public consensus, or just generally what the majority of the public believes to be true, which isn't necessarily in line with the bulk of the evidence. Public consensus is clearly not a relevant benchmark for assessing the likelihood of a scientific claim. This is not to say that we should forfeit our critical thinking skills and automatically and blindly accept the scientific consensus or what the experts say, but it is a very good starting point to thoroughly understand the currently accepted wisdom before considering more minority or fringe positions. Let's be humble and acknowledge who the leaders are in their fields, and not so casually dismiss them because some alternate view sounds convincing to us or conforms to our beliefs. To quote prominent neurologist and skeptical writer Steven Novella, "For anyone trying to take a scientific approach to knowledge about the world, we must rely heavily upon experts, or those who are more knowledgeable than we are. There is no choice. There is simply too much specialized scientific knowledge for anyone to be an expert in everything, or even a significant portion of scientific disciplines." Let's remember that the existence of a scientific consensus does not mean there will be no dissenters from within the scientific community. There almost always are, but usually they're limited and insignificant in relation to the balance of evidence. It's also important to acknowledge that there are legitimate ways to question a particular scientific consensus. Though without expertise in a field, and thus the ability to come up with the evidence to do so, it's really not going to happen. Future scientific research will continue to update our understandings, refining currently accepted wisdom and seldomly discarding it. But the time to embrace such new understandings is when we can demonstrate it, not before, and not because we can point to other models that have been overturned in the past. And that is the subject of the next video of this video trilogy: how scientific consensus changes over time. Thanks for watching.